Hey, what's going on, guys? Let's do this problem right here. So we have PV diagrams, and the question is asking to find the total work done in each diagram, right? So let's look at the first diagram that we have. So here we have this one. So PV diagram, and here the arrow is going from 1 to 2 and 3, and from 1 to 2 it's like the pressure is constant. If you see, it's a straight line, so pressure is constant, and from this straight line, its volume is constant. So whenever we have volume is constant, that's an isochoric process. So we can, this is going to be 0, W is going to be 0 at this point, any vertical. So here also 0 in the second diagram. So let's see how we can calculate this one. So if we put the equation for this one, Wt is going to be W1 to 2, W1 to 2 plus W2 to 3, right? W2 to W2 to 3, right? So we have this one, and we already know W2 to 3 is going to be 0 because volume is constant, any isochoric process. So if you have volume is constant, we call it isochoric process. Any isochoric process, the work is 0. So here this is going to be 0, and this one 1 to 2, and this is an isobaric process. So whenever we have isobaric process, we can use this equation, that is P times delta V, right? P times delta V to calculate the work. So here, if you look at this one, we have one atm pressure. However, we have to convert this one into Pascal because we have to get the answer in joule, right? Or you can keep this as atm, convert this one into liter, multiply this one, and multiply both by 101.3. It will also work, but let's convert this one into Pascal and solve this one. So if you convert 1 atm into Pascal, that's going to give you 101 300 Pascal. So 101,300 Pascal times the delta V, that's going to be final minus initial. So here the final is 5 minus 2, 5 meter cube minus 2 meter cube, that's going to give us 3 meter cubes, right? So 101 times 300 Pascal times 3 meter cube, and that's going to give us 303 900 joule, right? So also we have to know how did we get the joule right here. If you know that Pascal is going to be Newton per meter square, if you don't remember that, you can remember pressure equation, that is force over area. So force over area is going to be Newton per meter square, right? Newton per meter square multiplied by meter cube, you will get Newton meter. Newton meter is equal to joule, and that's how we derived this one. So here we have total work is equal to 303,900. Let's look at the next one, next graph. Here we have this graph right here, and we know this is 0, 1 to 4 is 0 because again it's an isochoric because the volume is constant. So isochoric process work is equal to 0. So let's calculate the other one. Wt is going to be equal to W1 to 4 plus W4 to 3 right here, right? And 1 to 4 we know that is 0. W4 to 3 is the pressure is constant, so this is an isobaric process. So whenever we have isobaric process, we can use P is equal to P delta V, right? P we know that is 3 atm. We have to convert this one into Pascal. It's same, is going to give us the same value as this one because we are going to multiply 3 atm by 101.101,300. So that's going to give us 303,900, right? 303,900. 303,900 delta V. Delta V is going to be my final minus initial. Final is 5 meter cube minus initial, that's 2 meter cube. And if you calculate this one, this is Pascal right here. And if you calculate this one, that's going to be 3 meter cube, right? So 303 900 Pascal times 3 meter cube, and that's going to give us 911,700 joule. So we have calculated the total work for second graph right here. So let's go for the third graph. In the third graph, we have this line right here. So here we don't have a straight line, or we don't have any vertical line. So we can't really use these equations, but we can find out from another concept that whenever we have a PV diagram, any area underneath the diagram, like for example, if you calculate this for the first one, if you calculate this area underneath the diagram, since this is in vertical, there's nothing right here. So underneath this diagram, that's going to give you the work. For example, let's calculate this one. We have the height is 1 atm. We know that it's going to be 101,300 Pascal. And if you know the distance, this distance is going to be 5 minus 3, right? 5 minus 2, that's going to be 3 meter cube. And if you multiply, you will get the same answer. For this one, same thing. If you look at this area underneath this arrows, you will see a square kind of shape. So here this distance is 5 minus 2, 3. And here the total height is 3. So 3 times 3 atm, if you convert this one into Pascal, this you will get this value times 3. You will get the same answer. So here we can use that concept to find the total work. So here we are going to find the work from this one underneath this arrow. I mean underneath this arrow. So this is going to be this area. But this area we can divide into two parts, like a triangle and a rectangle, right? So let's shade this one with a different color. A triangle and rectangle. So what we can do is we can find the area separately and add them together. So here what we are going to do is W total is going to be equal to W triangle rectangle plus W triangle, right? So this is what we are going to do. So for the rectangle, we know that it's going to be length times the height. Length times the height, that's going to be what 1 atm is the height, and the length is going to be 3. 5 minus 2, that's going to be 3. So 1 atm is equal to this value, 101,300 Pascal. 101,300 Pascal multiplied by this distance, that's going to be 5 minus 2, we can just put 3 meter cube right here, right? Plus for the triangle, we are going to use half time height times the width. So here we know, let's put values. Half times the width is going to be 3, right? Same as this width. So that's going to be 3 multiplied by this height. This height is going to be 3 minus 1, that's going to be 2 times this is an atm, so I had to convert this one into Pascal, so I multiply this one by 101,300, right? 300, let's cancel this 2 and this 2, and that's going to give us 303,900, right? So this is also going to be 303,900. 3 times 101, so it's going to be 303,900 joule plus 303,900 joule, and if you add them together, you will get 607,800 joule. So this is going to be the total work from this graph right here, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.